Okay, this topic is evaluating an exponential function with base e, the natural number, that models a real world situation. Let's see that 3 times slowly. Okay, so first of all, we look at this. We're given a function. You could read through this as a skydiver falling near Earth's surface given by this following function, where t is measured in seconds. So if we've got anything given to us in seconds, we know that's the input, the t, or the x, as we're going to see in our calculator. We want to find the velocity after 2 seconds and after 4 seconds. These numbers, 2 seconds, 4 seconds, those are our t values, right? This is saying that t equals 2. This is saying t equals 4. So we want to come up with 2 values. A nice way to do this is using the decimals. You do it on the graph. We can also do it with the table, and we're actually going to do both so we can see it in both ways. You can also plug these numbers in on a calculator. So I'll show you that way too. We'll show you all three. So first of all, I'm going to put this in as a function, and instead of v of t, we can just use y equals, and then we type in the 49, 1 minus. Now, you could use the functions, I think. Let's see. We could also just use e. It will interpret e as the number e and not a variable e. Just see if they have calculus. Yeah, we got a lot of stuff in here, but nothing really that we want to use. So we're going to use just the letter e. And notice it knows it's a number. We're going to put an exponent. Again, you could use this as our exponent, or you can use a shifted 6. Either way will do it. I'm going to use the variable x because what we're going to see is we're going to plug in the numbers. Well, that's for t, but I forgot there's this negative 0.17 that's in front. So I'm going to go up here, negative 0.17. There we go. And let's close off that parenthesis. So it looks just like what we've got here. We see it's going up, and if we want to find out what happens after 2 seconds, we can kind of see very easily that we're going to have to come up here. Now, if you want to do this graphically, let's out a little bit, get that out of the way. One way you could do that is, let's say when t equals 2, x equals 2, x equals 2. So it gives us the vertical line, and we get an intersection. We've got our value here. It's going to be when t equals 2, the output value is going to be 14.12. Round your answers to the nearest whole number is necessary. So if we round 14.12 to the nearest whole number, that'll be just 14. Right? So we could actually put that in here. I'm going to show you there's another way we can do this as well. We're going to get the same values, but you can take your choice. If we want to find out when x equals 4, what we would do is we just change this to 4. And notice we're going to have to come up further, and we see the intersection. So if we click here, it gives us the intersection. When x equals 4, we get 24.17. So 24.1, that's going to round to just 24. So we have that there. Okay, so that's using the graphing tool. But notice we had to kind of move the graph around to be able to see it. And depending upon the values here, it might be pretty high. Another way to do this, again, yeah, we're done. If you like this, we're good. But you might see, depending upon your thing, is we might use the table. And again, in here, instead of y1, we'll just type in this, 49, 1 minus e raised to the minus 0.17. 0.17 x1. Now, when we're doing it in the table, since our table has x1, we have to use x1. And then we arrow over, and we finish off the parentheses. And now we can come back here. And if you want, you can make this a little bit bigger so we can see everything that's going on. We can plug in 2, and we can plug in 4. And we get the table of values here. This is very helpful if the graph is like really large or we're not able to find the graph as easily as we did here. Um, and but we can see here's those 2 points that we got, and the value would be rounded to the nearest whole number would be 14 and 24. One final way to do this using the Desmos calculator is if you wanted to do this, and I don't know why, but you could actually physically type in each of these values, e raised to the negative 0.17, and we're going to have that times, it's just a shifted 8. Let's see, can we do that? Times, be up here. I don't know if it's like it's dropping it down. I need to multiply this times 2. Times 2. It's not working. Okay, what I think needs to happen, this is why it's harder this way, I need to have the exponent in a parentheses as well so that the system knows to keep everything up there. And see, now it's going to get me to times 2, and then I can come out here, close that, and I still get my 14. And then I come back, oh, they also wanted at 4. So it's not too hard once you put it in this way if you want. There's the 4, there's the 24. We get the same values, multiple ways to approach this, however you want to do it. One's a little bit more concrete. The table is kind of nice. If you just do the table, all you're getting is the values. But if you graph it and do the table, you'll see the points from the table getting there. And notice you can change these colors. Green, there, the points are now green. You change this, which is, again, and since it's kind of I think maybe you wanted a dashed line because it's not really part of the function. Maybe make it, whatever you want to do with it. You can do a lot of different things with Desmos to make your learning fun and visual as well. Okay, so anyway, those are the 2 values, and that's that topic.